Today is our last day in our transformations notes. So just a brief refresher, transformations is our entire unit. It's our umbrella term for moving and transforming figures on the coordinate plane. So it's a change in position, shape, or size of a figure. So the three types of transformations that we're talking about keep the figure congruent, which means that it stays the same size. We've talked about slides, which is our translations, which we covered in this section here. And that's just when we move the figure left, right, up, or down. We've talked about our flips, which is our reflections down in this section. So that's when it's reflected over the X or the Y axis. And then our last one is going to be turns or rotations, which is what we're going to cover today. And I'm going to be honest with you, it's going to be a little bit hard for me to teach this on the computer. It's hard for me to teach this in class because it's one of those things that you have to really think about and be able to visually understand it. So if you need to, go ahead and watch this video a couple of times until you understand it. If you need to, ask me some questions because I am here to help you. So let's go down to rotation. So rotations are our turns. So let me pull out my mouse. There we go. And text. So a rotation is a transformation that turns the figure about a fixed point called the center of, I'm guessing you can guess this, rotation. So we're going to have our center of rotation. In 8th grade, your center of rotation is always going to be the origin. So that means that it's the center of the graph. So it's where 0, 0 is. A figure that has rotational symmetry. So rotational symmetry. So E-T-R-Y. A figure has rotational symmetry if it can be rotated 180 degrees or less and match the original figure. So we're going to talk about that and go into a couple of examples. But first, let's finish out these notes up top. So rotations in our book, typically, most of the time, are going to be counterclockwise. I will give you some things that are clockwise as well, but a lot of times we do things in a counterclockwise motion. Clockwise. And there's a reason for that. So think about a clock when you are rotating things. And that's what I mean by clockwise and counterclockwise. If you think about a clock, it goes around like this if you watch the red hand. Counterclockwise just means the opposite direction. So we're going to be going around this way. And the reason for that is once you get into higher levels of mathematics, you're going to be doing a lot of rotation, a lot with circles, and those are all on the coordinate plane. And when you're talking about the degrees of the rotation, it's always in that counterclockwise motion. So you're going to be going counterclockwise a lot throughout all of your years of mathematics. So now that we've talked about that, let's go ahead and get back to rotational symmetry. So when a figure has rotational symmetry, the angle measures that it rotates is the angle of rotation. We find this angle by looking at how many times you can rotate an object and it remains the same. Then you divide that number by 360, and that's going to be the angle of rotation. And so I've got an example for you right here. So I've got a little plus sign. So in the object to the left, we can rotate it in 4 different positions without it changing the shape. So when I'm looking at this, I'm going to use this button to turn my screen counterclockwise. So right now it's a plus. When I rotate it again, it is still a plus. I rotate it again, it is still a plus. And then I rotate it for a 4th time and it's still a plus. Me rotating it 4 times didn't change its shape at all. However, let's take a look at one of these examples down here. If I look at this little, I don't know, snail shell looking thing, we've got the snail shell circle and then a little out jet on the bottom. If I rotate it counterclockwise, it is not the same shape anymore because we've got the circle, but the little snail shell part of it is going up. So it looks more like a house chimney or something. And so I'm going to keep going. No, still not the same. No, still not the same because it's on the left side now. And then once I rotate it 160 degrees, it's back to that same shape with the little outjet on the bottom. So for the original problem that we were talking about, that plus, it does have rotational symmetry. For this shape right here, it does not have rotational symmetry. So let's go ahead and write that really quickly. So this one does not have any, so we're going to say none. And then this time we were able to rotate it 4 times. So I'm going to write that number down. We were able to rotate it 4 times. So if we take 360 degrees, which is the amount or the degrees that we rotated it. So when we do a full 360, we turn completely around. Half of that's a full 180, and that's just turning around from front to back. So a full 360 is going to be a complete turnaround. So we're taking that complete turnaround and we divide it by 4 times because that's the amount of times that it came back to the original shape. And then that's going to be 90 degrees. And so we would say the angle of rotation is 90 degrees. So go ahead and see how many times you can turn these. If I rotate it like this, it's going to still be the same shape there. And it's kind of hard to do this on the computer, I know, because we can only rotate by 90 degrees. If you want to rotate your screen, you can also do it by 90 degrees. If you're on your Chromebook, I'm sorry, I'm going to have to clear my drawings. If you're on your Chromebook, this is how you do it. So you can always Google things. So I said how to rotate screen on a Chromebook. You're going to press the Control, Shift, refresh button at the same time. The refresh button looks like a curly arrow, and it's located just above the 3 and the 4 on your keyboard. If it has a pop-up window, select continue, and you should be able to rotate your screen. I can't remember if it rotates clockwise or counterclockwise though, so just keep that in mind because I'm pretty sure it's clockwise on yours. So if you're doing things in a counterclockwise motion, you're going to have to think about it just a little bit more. Woo. There we go. So go ahead and try these next 3 problems. See if you can like rotate it in any direction to get it back to the shape that you see when you're looking at it straight on. And here's your answers for the next 3 problems. So for the star, you can rotate it 5 times. So you see that there's 2 legs on the bottom. If I kind of turn my head, I can make these 2 the legs, I can make these 2 the legs, I can make those 2 the legs, and I can make those 2 the legs. So hopefully you can kind of see that. So that's me rotating it 5 different times. If I take 360 and divide it by 5, I'm going to get 72 degrees. This P has none. But this H has 2 because I can flip it 180 degrees and it still looks like an H. Let's look at this rotation example. So notice how the shape pivots from one point counterclockwise. So if we are rotating this original shape, if we rotate it 90 degrees, it kind of just stands back up. If we rotate it 180 degrees, it stands up and then it lays back down. 270 stands up, lays down, stands up, and then 360 brings us back to that original. And so when you are working down here, we're going to be rotating the figure counterclockwise 90, 180, and 270 from our point 0, which is our origin. So think of this point right here as your origin, and you're going to draw arrows to indicate your rotation. So go ahead and try these 2 problems. If you can figure it out, great. If not, just listen to this next part. So pause the video and try them. So here's the first one, just to give you a little bit of a hint if you need it. So we've got our rectangle and then our origin over here. So if I rotate it 90 degrees, it's going to make it stand up. We're looking at the origin here. So if I turn my paper counterclockwise 90 degrees, it's going to look like that. So let's go and try that out together. So basically what I'm doing is I'm just doing the rotation with my paper and then drawing what I see. So right now, this is the original figure. If I rotate it 90 degrees, it's going to look like that. And so what I see on my paper is a rectangle that's standing up with the origin just below it. And so when I go back, that is exactly what I'm going to be drawing. So I said that I am drawing a rectangle standing up, and I'm going to have the origin just below it. So there's my little dot. It's not the best drawing, but you get the gist. And then the label for the O is right there. And so that's all you're doing is you are rotating your paper, seeing what happens. So that was my 90-degree rotation. And we need to draw our arrows. So we drew our arrows going that way. Let's see what our 180-degree rotation is. So that was 90. This is 180. I see a rectangle that's laying down flat. I see the dot on the right and then the O in the middle. So let's go back to our original. That was our 90. I said that we are going to see a rectangle that lays flat. And then we have our dot to the right with our label in the middle. And so that's what it looks like. So that's all you're doing is you're thinking about, or you're figuring out what it looks like to be 90 degrees, 180 degrees, 270 degrees, whatever your amount of degrees are, and then just drawing what you saw. So bring it back to the original and draw what you saw. And that's exactly what you're going to be doing when you do these rotations, is you are physically rotating your paper using these clockwise and counterclockwise buttons, and then just drawing what you see. So when you get into your homework, we're going to be doing these kinds of things on our coordinate plane, and that's exactly what you do. So as long as you know how to rotate it and you can remember what you saw and where you saw it, you're going to be fine. So let's go ahead and look at the rest of these answers. And so here's my drawings for it. So this is the two drawings that I drew before, and then this is 270. And then this is how the smiley face is going to rotate throughout those three. All right, so now we have our rotation practice. And so what I'm going to have you do with this is you're rotating it. I want you to rotate it around the origin, not the center of the rectangle, because everything you're going to be doing is around the origin. So we already drew rectangle ABCD. And then the vertices are at those 4 points that are listed right here. So what I would do is go ahead and title those points just so it's a little bit easier for you. So A is at 0, 0. So I know that this point right here is my point A. And then B is at 0, 2. So 0, 2 is right there. So that's going to be my B. C is 4, 2. 4, 2. That's going to be C. And D is at 4, 0, which is right there. When you label your points, it makes it a lot easier to figure out where they're going because you have the labels for them. So don't worry about answering this. I just want you to rotate this around the origin, 90, 180, and 270 degrees. And then I'm going to have you skip this problem at the bottom unless you really want to do it because it's good practice, but it's not relevant to what we're doing here. So I'm going to go ahead and work with you on this first one so you can do the other two by yourself. So currently, this is our original rectangle. If I rotate this 180 degrees, or not 180, 90 degrees, because that's what I'm finding. What I'm going to do is I'm going to turn my paper 90 degrees. So this is me turning my paper 90 degrees. And I'm going to move these labels because they did not move with my paper. So A is there, B is there, C was there, and D is right there. this is exactly what you should be drawing on this one right here. So pretend that this is now the y-axis. This is now the x-axis. So A is still located at the point 0, 0. B is going to be located at the point -2, 0. And so I would recommend just writing this down because it's going to make your life so much easier. So A was at 0, 0. B was at -2, 0. Let's add some parentheses. What's going on up here? There we go. C is at -2, because remember this is our x, -2, +4. So let's go ahead and write that down. -2, +4. And then our variable D is at 0 because we're not moving left or right any, but we are moving up 4. So it's going to be at the point 0, 4. And so when I go back to my original, right here, this is what I'm drawing. So I'm going to put point A at 0, 0. Point B goes at -2, -2, 0. So -2, and then it's not moving any on 0. C is at -2, +4. -2, +4 is right there. That's really big. And then D is at 0, 4. So 0, 4 is right there. Since it is a shape, I'm going to draw lines to connect them. And then I'm going to add my labels because that's important. So A was at 0, 0. B was at -2, 0. C goes up here. And D goes right there. And so you can see that this is what we saw when we did our rotation. So I just worked through that first problem with you. I want you to try those next two on your own. So remember, you're doing these two problems here. Rotate this rectangle 180 degrees and 270 degrees. And then you can go ahead and skip this one if you're watching the video. If you have any questions, please send me an email because this one's a really difficult one to comprehend sometimes.